So list and stone are what we refer to as the two different memory addresses that keep track of field RNG in this game. So here is the grand concept. This is how field RNG works in this game. How it works is this game does not like generate a random number using like those like bitwise math functions or anything like that. What this game does is it's one of those games that has just every number from 0 to 255 shuffled into a hard-coded random, but not really random. It's hard-coded into a shuffled order that is always the same every single time that you play the game. This here is, and this is straight up. I'm telling you actual facts about the game right now. This is not theoretical. This is literal. This right here is the order of the random numbers in Final Fantasy VII. This is the RNG table. And what the game does, we've arranged it. There's 256 numbers, so we've arranged it in a grid from 16 by 16, but it just goes linearly through them. So it's left to right, and then it's this row left to right, and then it's this row left to right. They might as well just be a linear list, which they really are, but you'll see why we have them arranged neatly in a grid in a minute here. So this is the RNG table for Final Fantasy VII. And when you first boot up the game, your position on this list starts out at the 0 position, which happens to be the number 177, but that's irrelevant. Then what happens is every single time that a field script in the game wants a random number, it will advance your position on the list to the next position, and that is the number that will return to the script. So the first time that a script asks for a random number in this game, it gets 202. Every time. As long as, assuming that you've started from booting up your console, because, at boot up is when it's 0. The next time that you, that a script wants a number, it grabs the next number, and then it grabs the next number, and then it grabs the next number, right? And this is the sequence of numbers that it always gives, okay? This makes perfect sense so far, I'm sure. So, here's the deal. Your position on this list, this is a list of 256 numbers, and your position on this list is saved in a 1-byte memory address space, which we refer to as your list value. That is where you currently are on the table. So if we open up the emulator right now and see where we are, right now our list is 51, which means, so currently where we are in the game is our bookmark, our position on this list of random numbers is the 51st position, 51st. And then that means that the next time that RNG is called, it's going to increment that and return the next number to that script. So this number in memory saves your position on the list so that the game is able to keep track and always give the next number every time a script wants one. That should be very understandable. Let's see it in action right now, real quick. So this is a new game, right? And you see, list is 0, just like we said. The first screen in this game to have RNG values to have RNG calls is the next screen. So you'll see it sits here at 0 because nothing is calling RNG yet. But then when we get into the next screen, you can see list starts counting up. And so every time that list counts up, the reason that it counts up is because there is some script on this screen that is calling for RNG in order to behave a certain way. I've got my eye on this thing. I bet it's this right here, but I'm not sure. That might be waiting a random amount of time. This might be doing something random. Who knows? Something is causing list to increment. Okay, here's the Field and Mako reactor. Let's see what's calling RNG. Here it is. At least this is one thing that's doing it. So that's light 2. Ah, there's another thing. Okay. So 2 things in here are calling RNG. One thing is called ZZZ. Which, what is this? It's, let's see. Background parameter number 1. Which is either this. Ah, okay, so it's the sign. So one of them is the sign. There is something that's causing this intruder thing to change. Right? Background parameter number 1. As we can see right here, that's this sign. So that's calling RNG. Oh, yeah, yeah. So then if this other number, 525, is less than the random number that it chose, that's when it runs through the animation. Okay. And then, what was the other one? Light 2 uses random numbers. Yeah, right here it sets 533 random. And then it mods 3, adds 1. And then if that number greater than 0, that, okay, so that controls parameter 2. And yeah, parameter 2 is the glowing of the moist meter here. So yeah, so this thing glowing on is random. And then this thing. So anyway, that's just if you're interested. So that is why though that list is the this is the first screen that list actually starts to increment and random numbers start to get used. And now if we fast forward a little bit here, we'll see that once it reaches 255, when it hits 256, it's going to roll back over to 0. And so now the sequence of numbers repeats. So that same sequence of 256 numbers now repeats. Now, because there's 2 elements, though, the animation might not necessarily be the same. Because if it rolled over to 0, but they're at a different state than they started at, then that means that the animation is actually going to be different this time, and it's gonna count up differently still, and that's going to be very important later. That little detail. Okay, we now understand that the game runs through the same numbers every time that it wants random numbers. Now, though, we get to talk about the other element of Field RNG, which is stone. You may notice that stone is 1, and so when you start a new game, list always starts at 0, and stone always starts at 1. What is stone? Stone is actually the amount that list increments every time. So instead of list going up by 1 every time, that's not the rule. List doesn't always go up by 1. It doesn't always give the next number. It goes up by the amount that stone is. So if we were to just go in here and just poke stone to 33, you'll notice that now list increments by 33 every time that it goes up. And if we were to change it to 149, right? Now it's going up by 149 every time. I don't know if 149 is a valid stone though. And so what do I mean by that? So there are only so many valid numbers for stone, though. Stone is actually calculated using a number between 0 and 15. So stone is equal to some number h multiplied by 16, and then with 1 added to it. And then h... so first of all, h, though, is some number from 0 to 15, right? I don't know if curly braces is the right way to express this, but h is any number between 0 and 15, and your stone is 16 times h plus 1. So what that means is stone, it always starts at 1, but the only valid stones that you can get after that are 17, right, or 33, or 49, right? It's some number like 5, times 16 and plus 1. Yeah, it's got to be a number from 0 to 15, right? Because if H was 16, then it would be 257, and that, you know, that would just roll list. That would essentially be stone 0, because or be stone 1, you know, because list would just roll over the 256 and then add the 1 from the 257, and you would essentially have stone 1. So you could almost say that stone equals 16 times H mod 16 plus 1 if you wanted to get real fancy. But anyway, so stone is always a multiple of 16 plus 1. It's always a multiple of 16 plus 1. So every valid so all the valid stones, so that means that there are 16 valid stones from any number 0 to 15 times 16 plus 1. So what does this achieve? Why is that? What those different stone values achieves is it makes it so that you get through the order, you get through the list in a different order. So instead of it being one, you know, instead of the numbers that you get being 177, 202, 238, 108, 90, right? Let's say your list is 17. Then instead you're going to get 177, 160, 247, 233, 120, 221, yeah? And if your stone is 33, you're going to get 177, 115, 80, 146, 169, yeah? So it changes the order of the list without having to have a new list. Because every one of the different stones is going to return every single one of these numbers without repeating any of them before the loop starts over, just in a different order for different stones. And what the multiple of 16 plus 1 specifically achieves is that the plus 1, if you look at it on a 16 by 16 grid like this, it means that the plus 1 essentially always moves you right a column, and then the 16 times H moves you a certain number of rows. You know what I mean? So a stone of 1 is like your H is 0 times 16 plus 1. And so that means that you move 0 rows each time. Stone of 1, you just keep moving right. 1 column to the right, 0 rows to the right, or 0 rows, you know? But if your stone is 33, that's 2 times 16 plus 1. And so it's like you're going down 2 rows and right 1 each time. You see? Which means from every list value, from any list value, from any one of these list values, the next list value that you return will always be one of these, depending on what your stone is. And then whichever one of these, your next list value is going to be one of these. You know? It always moves in that way. You may be asking, like, how much does this matter? And how often does stone really change? And the answer is, in the main game, almost never. But in the elevator, it changes a lot. So in the main game, the only places where stone actually changes is it starts at 1, like we said, starts at 1. When you initiate the squats minigame, it changes it to 33. And then when you go to Bone Village and you dig for the Lunar Harp, or when you go to Bone Village and you initiate the digging minigame, stone gets set at that point depending on what your in-game time is at that time. And that's the only time that it changes outside of the elevator. Those 2 times in the entire game are the only times that stone changes outside of the elevator, which is kind of why it's called stone, is because it's like set in stone, right? It doesn't change very much. It should be noted at this point that the names stone and list are just things that the community came up with. Basically Brutal. When Brutal AI was discovering this stuff, he kind of named the different names. It doesn't really matter what you call them. This could be your RNG table index, and this could be your RNG table index incrementer. You know what I mean? Like, that's what they are. But we just call them list and stone for short. So, does everybody understand everything so far? So how Field RNG works in this game is that you have a position called list. You have something that we call list that is keeping track of your position on the RNG table. Anytime that the game wants a random number, or anytime that a field script specifically wants a random number, what it does is it adds stone to your position on the table. So let's say it's 33, it adds that to your position on the table, and then that's the number that gets returned to the script, that the script uses. So there you go. That's how Field RNG works in this game. All the time. Alright? So now, it's time to talk about the elevator. Because when you press the button in the elevator, it sends you up a random number of floors. But, as you can tell, we have a very thorough understanding of exactly what random means in this game. And so, perhaps we could use that knowledge to our advantage